You've got years of photos, projects, and game saves sitting on one drive. One power surge, one ransomware attack, one clumsy coffee spill, and it's gone. Most people don't think about backups until they've already lost something, and the ones who do, half of them have a setup that wouldn't actually survive a real disaster. There are way more backup methods than you think. Each one protects you differently. Let's break them all down. Full backup. This is the method everyone pictures first. You copy every single file from your source to a destination. Every photo, every document, every system file. Nothing gets left behind. Think of it like photocopying your entire filing cabinet page by page. It's thorough, but it's brutally slow. A full backup of a 2 terabyte drive can easily take several hours. It also chews through storage fast. Running weekly full backups means you need terabytes just for copies. The key specs here are drive speed and connection type. USB 3.0 gets you around 100 to 150 megabytes per second. Thunderbolt or USB 3.2 Gen 2 pushes well past 1,000. For most people, running a full backup weekly or monthly is plenty. The other methods we're about to cover handle the gaps in between. The common mistake? Thinking one full backup on one drive means you're protected. That's still a single point of failure. Incremental backup. This is where backups actually get clever. After your initial full backup, an incremental only saves the files that changed since the last backup. Not the last full backup, the last backup of any kind. It's like only photocopying the pages you actually edited today. This makes them fast and tiny. A daily incremental might only be a few gigabytes. The tricky part is restoring. You need the original full backup plus every incremental in the correct order. If one link in that chain breaks, everything after it is useless. Most modern backup software handles this automatically though. Time Machine on Mac and Windows File History both use incremental style approaches. Millions of people are running incrementals right now without knowing it. For everyday users, this is probably your default already. The myth is that incremental backups are risky. They're not, as long as your software manages the chain properly. Modern tools are very good at that. Differential backup. This one sits right between full and incremental. A differential copies everything that changed since the last full backup. Not since the last differential, since the last full. Here's how that plays out. Monday you run a full backup. Tuesday's differential grabs Tuesday's changes. Wednesday's differential grabs Tuesday and Wednesday's changes combined. It grows each day, but restoring only needs 2 pieces. The last full backup and the latest differential. That's it. Think of it like a running tally that resets every time you do a fresh full copy. Differentials are bigger than incrementals, but much smaller than full backups. They typically grow to around 10 to 20% of a full backup size by end of week. This method is popular in business environments where reliable restores matter more than saving a few gigs. The mistake people make is confusing differential with incremental. They sound nearly identical. The restore process is completely different. Local backup. This is the oldest and simplest approach out there. You plug in an external hard drive, copy your files, and unplug it. Done. Your backup lives on a physical device you can hold in your hand. It's like keeping a spare key in your desk drawer. Fast, simple, and completely under your control. Speed depends entirely on your connection type. A USB 3.0 external drive moves around 100 to 150 megabytes per second. Thunderbolt 4 can push well past 1,000. For most people, a 2 to 4 terabyte external drive in the $60-120 range covers everything. Just make sure you actually plug it in regularly. Local backups are great for quick restores. They're terrible for disasters. A fire, flood, or burglary takes out your PC and your backup simultaneously. And here's the mistake almost everyone makes. They buy the drive, back up once, and then it sits in a drawer collecting dust for 2 years. Cloud backup. This is what happens when your backup lives on someone else's servers. Services like Backblaze, Carbonite, or iDrive upload your files to remote data centers. Your data sits in a server farm hundreds of miles away from you. If your house burns down, your files survive. That pitch alone sells it. The critical number here is your upload speed. Most home internet connections upload at 10 to 30 megabits per second. Your first backup can take days or even weeks for several terabytes. After that initial sync, updates are small and fast. Pricing usually runs $5 to $10 per month for unlimited storage on one machine. Cloud backup is ideal for protection you never have to think about. It runs quietly in the background, always current. If you're running a cloud backup right now, drop which service in the comments. I'm genuinely curious what people are actually using out there. The big myth is that cloud backup and cloud storage are the same thing. Google Drive and Dropbox sync your files. They don't protect against ransomware or accidental deletion the way a dedicated backup service does. NAS Backup. NAS stands for Network Attached Storage. It's a small dedicated box with multiple hard drives sitting on your home network. Any device in your house can access it like a shared drive. Think of it like running your own personal cloud server in your closet. Most NAS units from brands like Synology or QNAP have backup software built right in. They can back up your PC, your laptop, and even your phone automatically. Some will pull data from cloud services too. The specs that matter are drive bays and total capacity. A 2-bay NAS with two 4 terabyte drives gives you solid storage with redundancy. Pricing starts around $150 NAS 200 for the unit alone, plus the cost of drives on top. A NAS is perfect for households with multiple devices. It gives you cloud-style convenience without the monthly fees. The mistake? Treating a NAS as a complete backup strategy by itself. It's still sitting in your house. Same fire, same flood, same vulnerability as any local drive. System image. This one works differently from copying individual files. A system image captures your entire drive as a single snapshot. Operating system, installed programs, settings, drivers, the whole thing. If your main drive dies, you restore the image onto a new one. You're right back where you were. It's like cloning yourself. Not just your memories, but your entire personality. Tools like Macrium Reflect, Clonezilla, and Windows' built-in backup utility can all create system images. A 500 gigabyte drive with 200 gigabytes used creates roughly a 100 to 150 gigabytes compressed image. System images are perfect for total disaster recovery. Your PC dies, you drop the image onto a fresh drive, and you're running in under an hour. The downside? They're big, slow to create, and go stale fast. The mistake is creating one image and then never updating it. A 6-month-old image restores a 6-month-old system, with 6 months of missing updates and patches. RAID. Let's get this one settled right now. RAID is not a backup. It stands for Redundant Array of Independent Disks. It spreads data across multiple drives for speed, redundancy, or both. If one drive fails in a RAID 1 or RAID 5 setup, your data survives. Sounds like a backup, right? It absolutely is not. Think of RAID like a seatbelt. It helps in a fender bender. It won't help if the whole car gets stolen. RAID doesn't protect against ransomware or accidental deletion. Delete a file from a RAID array and it vanishes from every drive simultaneously. RAID 0 offers zero redundancy. It's pure speed. RAID 1 mirrors 2 drives. RAID 5 needs at least 3 and can survive one failure. For most home users, RAID is completely unnecessary. A proper external backup covers you far better and costs way less. The myth here is painfully common. People hear redundant and assume it means backed up. It does not. Not even close. The 3-2-1 rule. This isn't a product or a piece of hardware, it's a strategy, and it might be the single most important thing in this entire video. The rule is simple. Keep 3 copies of your data. Store them on 2 different types of media. Keep 1 copy off-site. In practice, it looks like this. Your original files live on your PC. A local backup sits on an external drive. A cloud backup runs through something like Backblaze. 3 copies, 2 media types, 1 off-site. If 1 fails, 2 remain. If 2 fail, you still have 1. It's like having a spare tire. a roadside assistance plan, and a friend with a truck. You probably won't need all three, but you'll never be stranded. Following 3-2-1 doesn't have to be expensive either. A $70 external drive plus a $7 monthly cloud plan covers most people completely. The mistake is thinking the 3-2-1 rule is overkill for regular people. It's not. It's the bare minimum for anyone who actually cares about their data. We went from full backups copying everything in sight to incrementals being clever about it. From plugging in a dusty external drive to shipping your files to a server farm across the country. We busted RAID's undeserved reputation as a backup method. And we landed on the 3-2-1 rule, the strategy that ties this whole thing together. Your data deserves better than one copy on one drive. Treat it that way. What's your current backup setup? Cloud loyalist, local drive warrior, or still completely winging it? Let me know in the comments. If this video helped you out, hit the like button. It genuinely helps the channel more than you'd think. Next up, I'm breaking down every type of storage drive. SSDs, HDDs, NVMe, the full breakdown. Click the video on screen right now.